Hello friends, today, quick lesson in geometry. We're going to be talking about finding the area of a few different particular um, quadrilaterals. Okay, so we're going to start with finding the area of a parallelogram. If you have a parallelogram, you can find the area by taking the base times the height. Now, we got to be particular. The base, it's like, okay, what do we measure? Is it just this line or is it from here all the way like to this other corner? It's just the base from here to here. And then you multiply it by the height. The height, so this is called an altitude. It's from the top down to the bottom in a perpendicular line. So it's perpendicular to the base and goes all the way up to the top line to the other side. So that's what the height is. So the area is based on height. So here's a little bit of a kind of a demonstration of how this works. You can imagine, what if we take the triangle, this triangle here on the side, and we cut it off? Okay. What we can do is then take it and bring it around to the other side, and we can match it up here. And then that looks like a rectangle. Rectangle base times height. We've already seen that base times height is the area of a rectangle. Okay. Then also you can find the area of a trapezoid. Um, the way that I think about finding the area of a trapezoid is that it's base times height, except that we have two bases of different different lengths. Remember, a trapezoid, the bases are the parallel sides, has exactly one pair of parallel sides. But so it's not like, the whole base, because that's the same. Both bases are the same for the parallelogram. But here, it's kind of like you're taking the average of the two bases. So what would the average of the base lengths be? It would be base 1 plus base 2 divided by 2. And that would give you, right, base 1 plus base 2 divided by 2. That would be the same thing as 1/2 base 1 plus base 2. Kind of running out of space there. Right. And that's what we see here in the formula. So that's the average of the bases times the height. Another way of thinking about it is this. So what I'm going to do is I'm going to make a couple copies of this, and I'm going to take one of these, and I'm going to try to keep it the same size, and I'm going to try to flip it around. So oftentimes it gets bigger and smaller a little bit as I do that. But then when I match it up with this other one, notice that what I've basically created is a parallelogram. This side and this side. So it would be 1/2 base times height. So here's the base, here's the height. Or it would be the area of this whole thing would be base times height. But the thing is, this is two of the trapezoids. And so we're going to take half of that, or rather base 1, uh, here. So here's base 1 and here's base 2. So this is base 1 and base 2 added together, right? So this is base 1 here and this is base 2. So the whole base is base 1 plus base 2, and you multiply that by the height. That gives you the area of both of them together, and then you take half of that. So we get 1/2 of base 1 plus base 2. So two different ways of thinking about finding the area of a trapezoid. Also, the area of a rhombus. First of all, a rhombus is a parallelogram, so you can find the area of a rhombus using the parallelogram method, just base times height. But if for some reason you know the diagonals, then in that case, half of the product of the diameters is the area, right? So you find this distance and you multiply it by this distance, and then you take half of that product, and that gives you the area of a rhombus. So three different figures and a couple methods for finding the area of those. Thanks for watching. Don't forget to like and subscribe.